Welcome to another video on my Raspberry Pi 2 running Ubuntu Linux, equipped with a serial Pi Plus board with serial cable to Minicom terminal, HDMI cable for connection with this monitor, currently standby, and a band cable to a breadboard and a network cable for VNC. And the breadboard is right here. With some electronics and a bit of fischertechnik, LED and phototransistor. The objective, the target focus of this project is to gain control of the GPIO. And if you look here, this is the GPIO with the band cable on it, and this is then the other side of the band cable, obviously. And last time I tried it in C++, found out that the driver header file is for C, well, C and C++, but the example is in C primarily, so instead of C++ I'm doing C now, and found out that despite anything I tried, I had no result on the breadboard. No LEDs burning at all. So I also found out that during the from the examples of the header library, that the link options that I used were different and too few. So from that example I used 1, 2, 3, 4, 5, 6 different 6 link options, and that made it go well, except that it compiled but still nothing happening. So that's the current status, and let's see how things work out now, because yes, I can run the program, and let me try to do so. So using bash, yes, I can do things. Run this one, and it should run some more, but I see that the wire is out. Never a good point. This one is ook out, also on. Right now, let's do it again. No, that's the wrong command. So, go burning and burning. And yet again, this one is out, so I have to adjust the cable a bit. Do it again. On and not on. Yeah, now it is on. So that works from bash. Now let's see the software, because then you see something. Alright, so the bash test that I executed is given here. This is the actual content of the bash test, and here on the right hand side the program with all data extracted from the bash test. So if the bash test works, and then why doesn't it work? Well, one thing that was made clear, and I only found it out a bit late, and for that I have to go. No, let me keep this open. open a new terminal. That is it here? No, it's really in downloads. Oh wait, it is in, yeah, here. So, then again, wiringPi. Let's see for some examples actually. Blink, that's true. And here, right in the end of last time, I found this. wiringPi pin 0 is GPIO 17. So that's a bit strange. Is this okay? This is BCM GPIO 17, which is not pin 17. So in that perspective, I have to find out which pin it is, and I have to get the pin out. Let me get that one. So, pin out ready to see. GPIO 17. Well, this is pin 17, but GPIO 17 is here. Being pin 11. So, if GPIO 18 being pin 12 is then GPIO or pin 1, if, well, I can easily check that, of course. So, let's say pin 12, yes. So this would mean, and let me, pin 12, GPIO, GPIO 18. GPIO 18. Which would be pin 12. Pin 1 then. Not sure if that is correct, but let's assume it is. Alright, let's compile. Correct. Now execute. And that will be, by the way, oh wait, I do that wrong, because if it is 12, I should make this 1 as well. So again, compilation, and then ready to do, which is the green LED. So this one, if it works. Yeah, it does. It actually does work. So this means that I now have to put everything into perspective. This being, which one again? 18. Pin 18 is 0, 1, 2, 3, 4, 5, 6, 7, or counting outputs 0, 1, 2, 3, 4, 5. Let's say 5. Then it is either 22 that's going to burn, pin 15, or pin 18. So let's say 5. So here we state pin 18, GPIO, whichever that is, 24. This is 5. And then of course I have to change this into 5 as well. And now let's see what happens. Compilation and go. And now I'm extremely curious if the red one goes or not. Yeah, so it is 5. That means that only the green ones are counted. And of course it is nice if they go off. So let me change or add digital write 1 0 and digital write 5 0. Alright, compile, go, and then the go off. Yep. So, mystery solved. This also means that I have to do 22, 24 and 25. 22 is then, if this is 5 then this is 6. 22 is 6. And that is GPIO 25. Oh, I miss a slash here. And this is then, wait, what number had I in mind? 5, 6, alright. 6. Then this one is going to be 6. Test. Yep, all 3 burn and go off. Very good. Now then the next one. Oh, that's a nice one, of course, because 24 being what actually? That's a good question. Which is what? I have all 3 LEDs. So what more can be output? I think that's input. Yep. So then I think I should scratch this one and this one, and that's alright. Next attempt is C++, because that is the first focus. Is that going to be exactly the same or not? Let me keep the whole program inside, and then say, alright, VI, and it's called LED wiringPi.cpp, and that's the difference. Include, and this is going to be different because this is not STDI standard IO.h. I think this one, but I have to find that out. So let me write it and find out, because here I cannot make a mistake. Alright, I was wrong with this one, as I expected. This is supposed to be IO string. Very, very different. And I hope this is not different, which is wiringPi.h. Then this should be more or less the same. And there's one thing I wonder, and yes, this one I have to introduce as well, using namespace. Also very different. So that comes here. Using namespace std. And let's return 0. Do nothing, return 0. Or actually, this is not going quite right. And this is also very C, and I should do this correct. wiringPi C++. And I hope this is going to be correct. And I can only know that, or find out, when I do it like this. C++, CPP, and output CPP. No error. But will it do something? Yeah, wiringPi C++. So that is essentially correct. New line. So at least it takes a bit, but it works. So that means that this part at least is correct. And G++ compiler with all the options do work. That's good to know. And now the big thing is, will this work? So I'm going to copy this, go here, and hopefully being able to paste it. Yeah. So let's see if this one works. No, that won't work exactly, because let me take out this one and put it here, and then a digital write as well. Well, I can just do it like this. One. Then a delay of 500, and again a digital write, but then 1 0. So if this works out, I'm happy for the green LED. If it works out. And there we go. Oh yeah, right. I forget something here. Semicolon in the end. No compiling errors. And guess what? It works. Mind the green LED. So with C++, it's proven to work as well. Excellent. So I can control it. Can I control input? Because I do have a photo transistor. Output also with a propeller, which used to be here. I can still do that. And that was of course output 14 or output number 4. But having proven that it works in C as well as in C++, that's a very good thing. So I'm not bound to Bash anymore. It works now in Python, it works in C, and it works in C++. Very nice. And that's it for now. So let's run it again. This is in C. 1, 2, well, this is a wiring issue. Yep, because this works. Then the C++ version. Only this one for a short moment. And then the Bash version. 1, 2, 3. They all work. And that was the topic and main focus. Do I get it to work in all? Yeah. Thankfully I found out that wiringPi has the strange idea of setting pin 0 to the first pin that can be used for in and output. Logical anyway, but well, you have to know it. And then things are done like counting out and such. What will happen now? Well, further on, I hope with my ROS project. If not, I will build this out for something else. Anyway, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, very much appreciated. You can also follow me using or via Instagram and Twitter. Please donate to keep videos coming to you and to support my blog. You can support via PayPal and Wired, which is banking. You can also become a patron and have your name mentioned on my website, and depending on the pledge also with my videos. My website is mentioned under this video. So most likely to be continued. Have a nice day and bye bye.